Learn about the different logic gates. The logic gates have different symbols, which are shown here on the screen. The logic gates are OR, NOR, and NAND, XOR, XNOR, buffer, and NOT. So these are all the basic logic gates you need to know. Each of them takes two inputs, except the buffer and the NOT take a single input. So since a buffer is the easiest one, it just takes the input and passes it as the output. It just delays it a little bit. The NOT basically takes a 0 or 1 and turns it into the other number. So if you pass in a 0, the output is a 1. If you pass in a 1, the output is a 0. Now, the other gates take two inputs and do an operation on them. For example, the AND gate tries to see if both of the numbers are 1. If they are, then it outputs a 1. If either of them is a 0, then it outputs a 0. The OR gate takes two numbers, and if either of them is a 1, then outputs a 1. If none of them are a 1, then outputs a 0. The NOR gate is basically combining the OR gate and the NOT gate together in one gate. So it basically is going to do, if either of them is a 0, it will return a 1. And if none of them are a 0, then it will return a 0. The NAND gate similarly is AND combined with a NOT. So if both of the numbers are 1, it will return a 0, but if in all the other cases, it will return a 1. The XOR gate is exclusive OR, which means at least or exactly one of the numbers is a 1 and the other one is a 0. And in that case, it will output a 1. And the XNOR gate will do exactly the same thing, except it will output a 0 if either of them is a 1, or exactly one of them is a 1 and the other one is a 0. So these are the different logic gates. Now, what you can do is you can connect their inputs and outputs in whatever way you like, and the puzzle is that you're going to get two inputs, a binary number 0 or 1, and you need to add it to another binary number 0 or 1. And so create a circuit using any of these gates that you like that outputs the sum of the two binary numbers. And if you get it for 1 digit, you can try 2 digits, or you can even try something more generic with any number of digits as inputs. So that's your challenge for the day, and you can pause the video here to solve the challenge, and if you unpause the video, I will now proceed to showing you the answer. So the answer for a single digit binary addition is as simple as this circuit here, where you can see our inputs are A and B. You can see the sum symbol is the sum of the inputs, and you can see the C out is basically the carry. So if you try to add 1 and 1, the answer will be 0 with a carry of 1. So the inputs go through an XOR gate, and the carry is basically an AND gate, right? So the carry is only 1 if both of the inputs are 1. So you can clearly see why that's an AND gate. And then for the sum, if it's 0, 0, the sum will be 0. If it's 0, 1, then the sum will be 1. If it's 1, 0, the sum will also be 1. And if it's 1, 1, then the sum will be 0 with a carry of 1. So you can see when there's exactly 1, 1 and exactly 1, 0 in the inputs, that's when you get a sum of 1. So that is, as we learned, in an XOR gate. So this is it for this video, and I hope you explore more digital circuits and learn how to build more complex circuits using digital logic.